Okay, our next video for Module 14 is synthetic division, which I hate actually. I'm not a big fan of synthetic division. It's kind of a trick or a shortcut that is hard to remember, only works in certain cases, and doesn't really teach you anything. Okay, it's like it's very difficult to understand why it works, but it does. Okay, so definitely not one of my favorite things. And I can tell you right now, it's not going to be on a quiz or a test because I'm not a fan of it. I'd rather you guys do your long division the other ways that I showed you. But it is something that comes up here and there. So I'm going to show you kind of the algorithm for doing it. We are going to do x cubed plus 7x squared plus 4 divided by x plus 7, and they want you to write your answer as the quotient plus the remainder over x plus 7. Okay, so the first thing you do with synthetic division is under your division sign, you don't put the expression, you put only the coefficients. Okay, so we have a 1x cubed, a 7x squared, a 0x, and a 4. Okay, notice I put some spaces in between there because I'm not writing 1,704. All right, I'm just writing the coefficients. And then when I divide by x plus 7, I actually divide it by -7. You take the opposite. So think about it as x minus -7. Okay, so that's how you set it up. All right, now the first thing you do is you drop down the first coefficients. I'm going to put this little line here. Okay, you drop the 1 down. Okay. And then you do -7 times 1, and you put it right here. Okay. So there's your first step. I'm going to switch colors. The next thing you do then is you add. So the 7 plus the -7 is 0. Okay. And then you do the same thing. -7 times 0, put it here, and I get 0. Switch colors again. Add, and again, I get 0. There's a lot of zeros in this one. Okay. And again, -7 times 0 is 0. And I add, and I get 4. Okay. And notice the zeros don't really matter. They could really be any number. Okay. But then what you end up with is this last number is always the remainder. And these first are the other numbers are your coefficients. Okay, so I'm going to have 1x squared plus 0x plus 0. Okay, it always goes in order like that. You're never going to like skip one. Like this last number will be your constant. Second to last will go before an x. Third to last will go before an x squared. If I had more, there'd be an x cubed, x to the 4th, and so on. So there's my quotient. And then my remainder will be 4. Okay, so I'm just going to take out those zeros, and it's just going to be x squared plus 4 over x plus 7. Okay, that's your final answer. It is less work than your other division, like I said, but it's weird, and it doesn't make much sense, okay, unless you really take the time to think about it. But you can follow the steps and kind of learn a neat new trick, okay? The next topic here is using the remainder theorem. The way that they have you use it here is a little bit backwards. The next topic actually has a better application to it, but using the remainder theorem to evaluate a polynomial. Okay, well, first of all, you need to know what the remainder theorem is. So your remainder theorem is if a polynomial P of x is divided by x minus c, then the remainder, is P of c. Okay, so what they want you to do here is use the remainder theorem to find P of negative 3 for P of x is 2x cubed plus 4x squared minus 3x minus 3. Okay, well, this is where it's a little backwards. You could just plug negative 3 into that expression and get your answer. Okay, but what they want you to do, here, we usually do, P of negative 3 is 2 times negative 3 cubed plus 4 times negative 3 squared minus 3 times negative 3 minus 3, and get your answer. Okay, using the remainder theorem, okay, do P of x divided by, notice that c is negative 3 in this case, so x minus c would be x minus a negative 3. Okay, so we're going to divide by x plus 3. Okay, and that P of x is 2x cubed plus 4x squared minus 3x minus 3. Okay, and then the remainder is going to be P of negative 3. So it seems like a lot of work to just find your remainder, but that's what they want you to do. Okay, and if you look at the problem, they do have you have to find the quotient and you have to find the remainder, so they don't let you just kind of skip and do it this way. Okay, they'll show you it using synthetic division, which we know from the last video that I'm not a big fan of it, so we will do it using our Polydoku. Okay, so we're going to divide x plus 3. Our goal is 2x cubed plus 4x squared minus 3x minus 3. So we're going to put a 2x cubed here, which means 2x squared, 6x squared. We want a 4x squared, so we're going to do a minus 2x squared. So then minus 2x minus 6x. We want a minus 3x, so we're going to have a 3x here. And then 3 and 9. There's our quotient. Our remainder to get us to negative 3 would be negative 12. Okay, so our quotient is 2x squared minus 2x plus 3. Our remainder is negative 12, and that means that P of negative 3 is negative 12. Okay, that's kind of neat how that works out. But yeah. Okay, next one is kind of how you would really use the remainder theorem. Kind of in reverse, it's called the factor theorem. Okay, so the factor theorem basically says if we use the remainder theorem and we get 0, then we have figured out a factor. Okay, so let me get it written out for you here. Your factor theorem says that a polynomial P of x has a factor x minus c. It's a minus if and only if P of c equals 0. Okay, so they want you to determine if x minus 2 is a factor of P of x equals 2x cubed minus 2x squared minus 3x plus 4. Okay, so all we need to do, if we have x minus 2, that's x minus c, right? So c is 2. Okay, so we're going to find p of 2, which is 2 times 2 cubed minus 2 times 2 squared minus 3 times 2 plus 4. 2 cubed is 8, so we have 16. 2 squared is 4, so we have minus 8, minus 6 plus 4. Let's see, 16 minus 8 is 8, minus 6 is 2, plus 4 is 6. P of 2 is 6. It's not 0, so x minus 2 is not a factor. Okay, and it also tells you that if you were to divide p of x by x minus 2, the remainder would be 6. Kind of tells you that, right? Okay. All right, those are kind of two interesting little theorems here. Next one. And you guys, this next one you did do in Algebra 2, okay? Using a given 0 to write a polynomial as a product of linear factors. And this is again with just real zeros. Okay, so you have written polynomials as products of linear factors, but only when they're quadratics. And you have done that by factoring. Okay, so we have f of x is x cubed minus 3x squared minus 3x plus 1. And we're supposed to write it as a product of linear factors. So you're like, we don't know how to factor that. And you're right, we don't. But they give you -1 is a 0. Okay, so they want you to factor this knowing that -1 is a 0. Okay, so since -1 is a 0, x plus 1 is a factor, and I can factor it out through long division. Okay, so I'm going to divide x cubed minus 3x squared minus 3x plus 1 by x plus 1. And I know it will go into it evenly because I was told that -1 is a 0, which means x plus 1 is a factor. So I'm do x plus 1. And my goal, x cubed minus 3x squared minus 3x plus 1. So put my x cubed here, which means x squared here, x squared here. I'm going for a -3x squared, so -4x squared here, -4x, -4x. And I'm going for -3x, so an x, 1, 1. And again, there should be no remainders when I'm doing these. Okay, so now I have f of x is x plus 1, and the other factor is x squared minus 4x plus 1. And now I can finish factoring. Okay, let me see if did I mess something up? I feel like I did. Unless x squared minus, oh, I guess I can't. Oh, I see what they want you to do. Okay. Sorry, now this is not factorable. Okay, but it is not a linear factor. So we use the quadratic formula actually on that. Okay, so we can't have any x squareds. That's a quadratic factor, not a linear factor. So now what we need to do is use the quadratic formula to solve 0 equals x squared minus 4x plus 1. Okay, so a is 1, b is -4, and c is 1. So x will be the opposite of b, plus or minus your square root of b squared minus 4 times a times c all over 2a. Okay, so we're going to have 4 plus or minus the square root of 16 minus 4 all over 2. So 4 plus or minus the square root of 12 over 2. And we do need to simplify these all the way. Okay, so then we have 4 plus or minus square root of 12 can be split into square root of 4 times the square root of 3. So 2 square root of 3 over 2. And then we can factor 2 out of both the numerator and the denominator. Okay, and then we can cancel them. Oops. So x is 2 plus the square root of 3 or 2 minus the square root of 3. Okay, so those are your zeros. So then your factors are x minus 2 plus the square root of 3 and x minus 2 minus the square root of 3. Okay, and now we need to include our original factor, right, the x plus 1, to put it all together. So f of x is x plus 1, x minus 2 plus the square root of 3, and x minus 2 minus the square root of 3. That's a lot to chew off there. Okay, but you're going to follow those steps for every problem like this. In fact, I'm going to look at the next one quick in my worksheet here and just make sure that they're all going to be real similar to this. Okay, so I'm going to go back up here and just kind of reiterate there. They give you this. Okay, your first step is to figure out with your known zero what a factor would be and then divide. Okay, and so then you have something that looks like this. And then your next step is going to be to use the quadratic formula on that second piece there. Okay, just be real careful. A lot of kids mix up going from the zeros to the factors here. Remember, if you have a 0, x minus a 0 is a factor. Okay, so both of these are going to be subtraction signs, always. Okay, and then it's here where you're going to have the plus or minus. All right. Okay. All right, let me get another one here. We're getting close to the end here. Yeah, we're almost done here. This is a really interesting module. I like it a lot. It's like a lot of logical steps here that kind of like pieces that you put together. And I think that's more interesting than like some of the other types of problems that you've been doing, but I don't know. All right, finding all possible rational zeros using the rational zeros theorem. And this one is problem type 1. Problem type 2 is going to be the next topic. Oops, I said 2 and meant to write 1. And it's going to be really similar. And then we're going to be done with this module here once I finish that last one. Okay, problem type 1. All right, so use the rational zeros theorem to find all possible rational zeros of g of x is 2x cubed plus 3x squared minus 3x plus 7. Okay, so now we're not saying that these are all have to be zeros, but if there are zeros, they're going to be on our list that we come up with. Okay, so the way that this works, your rational zeros theorem, okay, if a polynomial has zeros, I should say rational zeros, then they can be written as P over Q. Okay, and now what's P and Q? P is a factor of the final constant. Q is a factor of the leading coefficient. Okay, so in this case, that final constant is 7. The leading coefficient is 2. Okay, so you list, factors of 7. And make sure you get the negative ones in there too. Okay, so factors of 7 would be positive, -1, positive, -7. Okay, factors of 2, positive, -1, positive, -2. Okay, now remember, factors of 7 will give you your P's, factors of 2 will give you your Q's, and we get all the possible combinations. Okay, so your possible zeros would be, and it's just all positive, negative, right? We could have from P 1 over 1 or 1 over 2. And then we can move on to the 7, excuse me, 7 over 1 or 7 over 2. Okay, so, and we can simplify those ones that are over 1. So positive, -1, positive, -7, positive, -1/2, positive, -7/2. So there are 8 basic candidates for zeros of that function, okay? And I would encourage you, graph it and see. Go ahead and graph that original function. Again, if you use Desmos, you can just click right on the intercepts and see. Anytime that this original function would intersect the x-axis, it's going to be one of those 8 numbers. Okay, and again, they're not all 8 zeros, but if there are zeros, they're going to be one of these 8 values. Okay, we're going to do another one because problem type 2 is very similar. Problem type 2 just has possible repeats that you have to eliminate. Okay, and then that's the last one for the module. The last one is finding, again, all possible rational zeros using the rational zeros theorem. Problem type 2. Okay, so this one, we have g of x equals 15x cubed minus 4x squared minus 5x plus 9. Okay, so again, p will be factors of 9. Q will be factors of 15. Okay, so all your factors of 9, you have positive, -1, positive, -9, and positive, -3. Factors of 15, positive, -1, positive, -15, positive, -3, and positive, -5. Okay, so now there's a ton of combinations here, right? We do all your P's over Q's. You start with the 1, so you'd have positive, -1 over 1, positive, -1 over 15, positive, -1 over 3, positive, -1 over 5. Now we're going to move to the 9, positive, -9 over 1, positive, -9 over 15, positive, -9 over 3, positive, -9 over 5. And now I'm going to move to the 3, positive, -3 over 1, positive, -3 over 15, positive, -3 over 3, positive, -3 over 5. Okay, what makes this different than the previous problem type is that there's repeats here. Okay, so we're going to eliminate any repeats, and we're going to reduce these fractions to do it. So any fractions that we can reduce, positive negative 1, this one will be positive negative 9. This would be positive negative 3/5. Okay, if you reduce your fraction, 9/15 reduces to 3/5. This will be positive negative 3. This one is also positive negative 3. This is positive negative 1/5. And then we have positive negative 1. Okay, use a different color here so we can eliminate any repeats. Okay, so we have positive negative 1. So we're going to eliminate this guy. Okay, positive negative 15, I don't see anywhere else. Positive negative 1/3, I don't believe I see anywhere else. Positive negative 1/5, I'm going to eliminate that guy. Positive negative 9. Okay, positive negative 3/5. 3. Oh, 3/5. And there's another 3/5 over there all the way to the right. There's another 3. And then we get our 9/5. Okay, so I don't think I have any repeats now. 1, 2, 3, 4, 5, 6, 7, 8, which would be a total of 16 possible zeros, right? Okay, so you can leave the positive negative there, or you can list them all out. So your answer, positive negative 1, and it doesn't matter what order you do it in. Okay, you could write it like that, or we could write it like that. Okay, either one of those lists would be acceptable answers. All right, and I think that is our last topic for Module 14. Let me just double check. Yep, that's it. Okay.